Suppose we have this A and B in the coordinate system, x and y, and C is sum of A plus B. We want to find C, magnitude and direction. Then, if you look at the components here, this is component AX. This one is BX. And from here to here, if you look at C, this is CX. Right? And then the same way this way, this is AY. And from here to here is BY. And from here to here is CY. So you can see that CX is AX plus BX, and CY is AY plus BY. If you have more vectors, you can add the x component of all vectors. So it doesn't get too much more complicated if you have more than two vectors. And no matter how many vectors you have, you just add all the x components. That gives you the x component of the total. And all the y component gives you the y component of the total. Then when you find the x component of the total and the y component of the total, you know how to find magnitude and direction. That makes it very simple to deal with. So this is how we add vectors. We split them into their components. Add the x components, we get the x component of the total. Add the y components, we get the y component of the total. And then from the x and y component of the total, we can find magnitude and direction of the total. As an example, in a reality TV show, a few groups of contestants, for each one, they give them some equipment like a compass to find the direction, and a calculator, a shovel, 3 displacements from one point in the field. 3 displacement, A is 75 meters in direction 30 degrees east of north. The other displacement, 56 meters, 20 degrees south of west. Another one, 20 meters, 30 degrees south of east. 3 displacements. And they said from that point, these 3 displacements lead to a point where if you dig, you find the key to a house. You can have the house. So they have a compass and they can go in some certain direction, they can measure the length. They start measuring. The winner actually calculates first. What do you think they calculate?
So they can go like right to it?
Yes. Yes. Take a look at the sketch of these 3 displacements. 75 meters, 30 degrees east of north. So that's 30 degrees east of north, and it goes 75 meters there. That's 30 degrees. And that's vector A. And then from there, 56 meters, 20 degrees south of west. West is this way, right? This is x direction, which is east. This is negative x direction, which is west. This is y direction, which is north and south.
Is that 56 or 50?
56. 20 degrees south of west. So west is this way, 20 degrees south. From here is that if you draw horizontal line parallel to this, 20 degrees is this way. Maybe longer. And then 20 meters, 30 degrees south of west, south of east. And from here, east is this way, 30 degrees south is this way. I don't know whether it comes to y-axis or not, we have to figure that out. So that's B, and this is 20 degrees, and that's C, and this is 30 degrees. And so we want to add these 3 displacements. So how do we add? First find all the components, right? How do you find the components?
Magnitude times cosine of angle, and then
Yeah, now because you have 3 of these and they're all in crazy directions, it is best to find the angle for each one, the standard angle. It's easier to do that, right? What is the standard angle for A? Let me call it theta A.
60.
60 degrees. From positive x direction to this is 90 minus 60. Minus 30, which is 60 degrees. What is the standard angle for B?
200.
For B is this one. It goes from here 180 plus 20. And theta C?
330.
Yeah, you can say 270 plus 60 or 360 minus 30. Or you can say just negative 30. If you go clockwise, you count negative. You can say negative 30 degrees or 330 degrees. Both of these would work the same way. So we use negative 30 degrees. And then for each one, x component is magnitude times cosine. Because there are so many directions, it's best to do this, and now we don't have to worry about positive, negative, or sine or cosine. We know all the x components come with cosine, all the y components come with sine, and the positive, negative is automatically there. So we say ax is equal to a cosine theta a, which is a's magnitude, 75 meters, times cosine of theta a, which is 60 degrees. Ay is 75, and a sine theta a, 37.5, right? 5. Give me 3 sig figs.
Okay, 65.0.
0.2,
No, 0.0.
0.0, 0.2. Because these are meters, we are interested in at least 10 centimeter, right? If you want to dig a hole, it's 10 centimeter higher and lower, it doesn't matter. Your hole will be at 20 centimeter away. So again, Bx is 6 cosine 200 is 6 sine 200 degrees. How much are these? 2.6.
And the second one is negative 19.2.
19.2, thank you, meters. I'm a little bit disorganized here. Cx magnitude C cosine theta C. Magnitude C is 20 meters, cosine negative 30. For cosine negative positive doesn't matter, so that will be 17.3. Cy,
Yeah, 17.
17.3 meters. And y component of C is C sine theta C is 20 meters, sine negative 30. Sine negative 30 is negative 1/2, so it becomes negative 10 meters, right? All right. So now, if you want the total resultant vector R x equal to ax plus bx plus cx. So that's 37.5 minus 52 plus 17.
2.2.
2.2. Ry,
35.80.
ay plus by plus cy.
35.
35.8
8.
meters. Now, you just need to go 35.8 meters in north direction and then go 2.2 meters to the right. You're right there. But I think it's around here, right? It goes a little bit this side. So not only it is easier to get there after you do a little bit of calculation, but also you're more precise because when you're measuring, going here, you have some error in your measurement in length and error in your angle. So you end up going somewhere around here. And then wherever you are, then you go another one, this error becomes larger. And then if this becomes even larger here, then you dig a hole, it's not there because you're not precise. But this way, you're more precise. You have only one measurement. Measurement is with error, right? So you have only one measurement, it becomes more precise. Not only it becomes easier to do, but also more accurate. So there are a lot of advantages. And of course, when you're doing calculations in like either computational, with computer, or other more complicated calculations, components are a lot easier to use in general.